Welcome to all. I am Dr.R.Kokila, Assistant Professor, Department of Mathematics, Sita Lakshmi Ramaswamy College, Trichy. In this video, we are going to see about transportation problem. So, transportation problem, the overview of this content is that is, we are going to see the introduction about transportation problem, types of transportation problem, and the various methods of initial basic feasible solution, and where we are going to apply that transportation problem. So, first we are going to see what is transportation problem. This is a special type of linear programming problem where the main objective is to minimize transportation cost. That is to transport goods from various origins to different destinations. That is, we are transporting single homogeneous commodity from different origin to different destination in such a way that the total transportation cost must be minimized. This is a special type of linear programming problem. Usually, linear programming problems can solve it by simplex method, but because of the special structure of this type of model, we cannot solve it by simplex method. So, we need a special method of solution. The aim is to find out the minimum transportation cost. And the transportation problem, that is finding the minimum cost distribution of a single homogeneous commodity from a group of supply center. There may be M centers, and from that centers to end destinations, we have to transport goods. So each source has a certain supply, and each destination has certain demand. The cost of shipping from a source to destination is directly proportional to the number of units shipped. And suppose if the demand and supply is equal, then the transportation problem is said to be balanced transportation problem. And if the supply and demand are not equal, then it is said to be unbalanced transportation problem. So these are the types of transportation problem. Next, to find out the solution of transportation problem, we'll find out the solution in two phases. In phase 1, we'll find out initial basic feasible solution. And in second phase, we'll obtain the optimum basic feasible solution. So these are the methods of transportation problem. For initial basic feasible solution, there are three methods available. One is northwest corner road, and another one is least cost method, or it is also known as matrix minimum method. And third one is Vogel's approximation method. So among these three types of initial basic feasible solution, Vogel's approximation method is the best method. And using these initial basic feasible solution, we'll obtain optimum solution. That optimum solution may be found out by using two methods. That is, one is modified distribution method, or it is also known as Modi method, and another one is stepping stone method. So these are the methods of initial and optimum basic solution. Now, first we are going to see the first method, northwest corner road method. The main areas of applications of this method, but the cost is not the main criteria. In that situation, we can use this method. So it is used for transportation within the campus of an organization as costs are not significant. And this definition of this method is adopted. It is a method to adopt the initial basic feasible solution. The name northwest corner rule is given to this method because the basic variables are selected from the extreme left corner, and it is one of the easiest method to obtain initial basic feasible solution compared to other initial basic feasible methods. And in this method, the steps of this method are: first we have to select the upper left corner of the transportation matrix and allocate the minimum of supply and demand. That is minimum of A1, B1 in the first cell 1, 1. And after allocating in the cell 1, 1, suppose if A1 is less than B1, then the next allocation is made in the cell 2, 1 for the remaining value. And suppose A1 is greater than B1, then allocation is made in the cell 1, 2 for the remaining value. And if both the supply and demand are equal, in that case, either we can allocate A1 or B1 and move to the next cell 2, 2. So in step 3, we have to continue this process until all the ring requirements are satisfied, and also an allocation is made in the southeast corner cell of the transportation table. So this is the algorithm of northwest corner road method. Now we are going to see an example of northwest road. So this is an example of source and destination. The supply amount is given as 7,918. So the supply total, it is equal to the demand total 58714. So this is an example of a balanced transportation problem also. And in this cell, using northwest corner rule, first we have to allocate in the cell 1 1. So minimum of 5 7, 5 was allocated in cell 1 1. Remaining value 2 is available in the first row. So in the cell 1 2, next allocation is the remaining value 2 and the second column demand 8. So minimum of 2 8 is 2, that is allocated in cell 1 2. Now first row is fully satisfied, but in the second column remaining 6 is available. So we have to allocate that 6, minimum of 6 and 9. 6 is allocated in cell 2 2. So after allocating 6, again in the second row balance is 3. So next we have to allocate in the cell 2 3 the minimum of 3 and 7. So 3 is allocated, second row is fully satisfied. Again a remaining value 4 in the third column. So that 4 is allocated in cell 3 3 with minimum of 4 and 18. And so after allocating 4, the third column is fully satisfied. So remaining value 14 is in the cell 4 4. So we have to allocate in cell 4 4 minimum 14 14. So that after allocation all the rim requirements are satisfied. So we have to calculate the minimum total transportation cost. So the basic cell into cost. So adding all the multiplication of all the values will get the minimum transportation cost as 1015. So this is the initial basic feasible solution of the transportation problem using northwest corner rule method. And another method, next method is the least cost method or matrix minimum method. In this method, we have to allocate first in the cell with the minimum cost. So that is the first allocation. After satisfying that, we have to move to the next minimum in the given matrix. So this method is used to compute transportation route in such a way to minimize cost but not in an optimum way. And then the third method is Vogel's approximation method. So among all the three initial basic feasible solutions, that Vogel's approximation method is the best method. Now, applications of least cost method, it is used in financial analysis, economic analysis, risk assessment, transportation, environment. So in these areas, this least cost method is used, and the Vogel's approximation method is used to compute transportation routes in such a way to minimize transportation costs for finding out locations of warehouses. And it is also used to find out locations of transportation corporation departments where insignificant total cost difference may not matter. So next we are going to see the general applications of transportation problem. It is used to minimize shipping costs from factories to warehouses or from warehouses to retail outlets. To determine lowest cost location for new factory, warehouse, office or other outlet facility, this transportation problem is used. And to find minimum cost production schedule that satisfies firm's demand and product limitations is also it is used. And it is also used in military distribution system, the airline industry, research and development, traveling salesman problem, transshipment, etc. In that areas also, this transportation problem is used. That's all. Thank you.